Okay, so in this example here, this is going to be problem 6. We're going to be taking a look at paired sample means, the difference in a paired sample mean. So what that means is, remember the first problem, problem 5, when we just did, we had two separate groups, a control group and a treatment group, and they were different people. But here, these are the same people. So we paired them with a before and an after pre-test and post-test. So we're going to actually just take a look at the differences of the scores and find the mean and run T's test on that. So it's really like treating it like one group actually. So it's actually going to have n equals 6 and degrees of freedom equals 5. So we're going to first take a look at our, let's take a look. Our null hypothesis is going to be that the difference in the mean differences are going to be 0, and that the alternate hypothesis would be that the mean difference is not going to be 0. That's going to be detailed. But again, all we're looking at is the difference of the two tests. So here I'm going to calculate my difference. I'll just do before minus after. Okay, so that's -4. So we actually did better. Let's go ahead and copy that down. Notice here they had the same score, so there was no difference, right? So this is going to be equal to the average. And I'll go ahead and select my differences. So my mean difference was -2.5, so everyone did better by 2.5. Then I need to take my squared difference again, so that's going to equal my difference minus my mean of my differences. I'll hit F4 to make it an absolute cell reference, and I'll go ahead and square that. All right, then I'll go ahead and copy that down. Okay, something didn't look right there. Let me see the formula. All right, so let's see this here. All right, let's try again. So this equals the difference minus my mean. And my mean I want to use every time, so I'm going to use F4. And then I'm going to take that whole thing, oops, and I'm going to square it. Okay, that looks better. And copy that down. All right, there we go. So the sum of squares is going to equal the sum of all these differences squared. Okay, and then I can calculate my variance by taking that sum of squares and dividing by n minus 1, which is 5. Okay, and I can find my standard deviation by taking the square root of my variance. So I got 7.3 standard deviation. All right, now to calculate my t statistic, I'm going to take the difference in my means, which we're assuming this is 0, so it's just going to be this -2.5, and we're going to divide that by my standard deviation I just found, divided by the square root, and we're going to use n, so we'll put 6 in here. Okay, so that's going to give us a test statistic of -0.8372. All right, so we can find our critical value is the same as the other problem. We could use our table, which I'm not sure where it went. But if you look at the table for a two-tailed test, it was 2.228. And that's going to be plus or minus, right? And then the p-value is going to be equal to twice the t-distribution of, let's say, we got negative 0.0 0.8372. And then we have 5 degrees of freedom now, and cumulative will put true. Okay, so 0.4406. Now, if we look at a picture, let's put this over here. All right, so here we have our picture. Here our distribution, let's say. And if we use our test statistic, negative 0.83, let's call it. And then here's one over here at 0.83. Okay, so our p-value is actually the probability in these tails. So it's getting twice one tail. And we can look at our test statistic. We can take our p-value, which we got to be 0.44, and compare that to our level of significance, which is 0.05, and see that obviously this is greater, so it's not less than or equal, so we're going to fail to reject. Fail to reject the null hypothesis. Okay. Or the other thing we could do is we could look at our t-distribution and put our TC's criticals, which was 2.228. And we can look at our test statistic. So this is our reject zone, our reject zone. This is our fail to reject zone. So this is 0 here. So, you know, negative point, whatever, negative 0.83 is right about here. So that's in our fail to reject zone. So that matches with that. What I wanted to show real quick was on the cell. Put this back over here. Using that analysis table. So here, you go to data analysis. This is going to be t-test with paired two-sample means. Okay, so we're going to use our before as one group, and we're going to use our after as another. Our hypothesized mean difference, we're going to keep it 0, and our alpha level, we're going to keep it 0. Okay, interested in new sheets. And let's go ahead and paste this in. Where is it? There, here it is. Okay. All right, so our critical value would actually be different. I had to find the Z table because this had 5 degrees of freedom, not 10. So here you can see here, if you look at the table, you see about 2.570. Okay. And then, so looking at our picture, we would just change this to negative 2.57. This would be 2.57. This again with degrees of freedom 5 instead of 10. Okay, so that actually makes sense. Notice here, again, degrees of freedom only says 5. The t-statistic, negative 0.83, is the same as what we kind of calculated, so that's good. And our p-value, 0.400, is what we got right here. So this one you also failed to reject, so really we're saying that the pretest post-test didn't really have much of a difference. Okay, thanks.